Let's take a look at the new board about to be made, sent. It is in production. There is, as a difference to the last boards, there is a possibility for a pin heater here for different supplying different voltages to different parts of the board. To pull out, to make a connector for power management. We will recognize again the two heaters for the Heltec, here the left one and the right one. And then we will recognize the UART connector that is continuing down here to the I2C and to the one wire. The idea is, of course, you can use one long, you will use one long connector here, but on the output side, if you only use this board without the extensions board, you can still just connect a UART or just connect an I2C. And for each of them, there is a 5 volt and 3.3 volt and a ground out for all of these three communication standards, and the same for the SPI over here. Now you would put in one long connector from below to the top here, but you could, if you only use this board with a few sensors, for whatever reason, you could, in the long connector, just connect a shorter one to this part and have an SPI running. Yeah. Just in the middle here, there's a voltage divider, open-ended here, so that you can configure it to the pins of the microcontroller, what you want. Yeah. And this from down here, we see the external of the microcontroller, the UART RxTX reset of the microcontroller, pin 0, 21, 20, 19, 7, 6, 5, 4, 3, 2, 1. These are the outputs or the connections that you can rewire or wire in here as you like. So the IC, the microcontroller, is put into, on the left side, this connector. And then in between the two connectors of the IC, you can see here GPIO 1. You can connect, for instance, whatever you like to the IO one wire. And the IO you will find just out here on the one wire. Or you can take pin 2 or pin 3, depending what hardware, software you want to have it running. So on the right side, we have the GPIO 46, 45, the pins of the GPIOs, and down below 35. And there is, for the Heltec version 3, Wi-Fi LoRa 32, there is a JTAG pins here. They are not connected to anything. The outputs from the MCU comes here. So you can maybe make a JTAG down here, or, something. Or you can use these four and actually wire a physical small wire up to the K6 to 9, maybe, depending what hardware you want to put in. Or just leave it. Then we have the SPI here, chip select, MOSI, clock, MISO, and this VP is for different ways to use SPI. And depending on how you want to do it, how many wires and functionality use in SPI, there is a VP pin 2 in here, 38. So just to the left of the right pin header going up to the microcontroller, you can see all these and you can access them. Just like on the other board, I can show you again in a second. And on the left, just to the right of the left connector to the MCU pin header, you can see what you can, all these you can pull out and connect to something. Let's take a look. SPI, we talked about it. There are actually 4 wires who are already wired. That is MOSI, MISO, clock, and chip select. You always need that for SPI as a minimum. So they are wired down here. And you don't, if it's a standard small SPI, it works with that. And then for the one wire, the wire for one wire is pulled out here. So you can say, okay, according to other hardware, software, I want to use it with 45. So you make a wire, physical wire from here to there, or 46, or 1 or 2 or 3, depending on what you win. Then you can say, what's K3? That's just going down to the big extension board, where there is a possibility to use K3 for something down there, whatever you want. So there are possibilities. This is free, not fixed to anything for now. There's for the I2C, SDA, SDC, it is just a hardware suggestion to use SDC with pin 5 or SDA with pin 4. And here is a small pad normally used for surface mounted devices. So if you say, I want to say, okay, let's put SDC to pin 5 on the MCU, you will solder a small cloud of solder over these 2 pins to shorten it. And the SDC connector out to the extension board will be attached to pin 5 on the MCU. And equally with SDA, here's another small pad, normally surface mount divided pad, but just shorten it, and you can use that. Or take a wire from this solder hole and put it on maybe 6, 7 or 45, 46. It's just a wire. I'll show again how it's done on the old version, just an example. Yeah. K1, K2 are free too. They just go to the extension board, the big board, so you can choose if you want to use them or not. K6 to K9, so everything K is not necessarily already wired. You can play around with it, you know. So that's extension board left over, free wires or connectors to left over to use for something. Often you will use this up here in prolongation of an SPI, a long SPI connector, where you sometimes would like more connectors for something. Maybe this SPI example where you need VP from pin 38 or from GPIO 38. You will maybe pull a wire from here up to K6. You will, etc., etc. So you can manipulate it a little bit. And you can see this line of, again, pads for surface-mounted devices. And that's just a little bit fun play. If you want to use GPIO 26 on K6, you will solder the upper here. If you want to use 48 instead for K6, you will solder this one, etc. So you, for K6, you can spontaneously, without finding a wire, you can just put a cloud of solder for this one or for the 48, and for the rest two here, K6 to K9, you have a little bit of possibility to, without a wire, to do some stuff there. But of course, you can use this hole here and with a wire going over to K2, K3, you can manipulate. You'll show you an example in a few seconds with the old version, or version 1 or 2 of the Heltec Wi-Fi LoRa. Anyway, this up here, what I've done here is separating the power for the sensors, or the power going to the extension board. I've separated from the power going to the MCU. And the idea is, with an external board or external electronics, it's possible to shut down the power for all the sensors for the extension board, but keep the power running for the MCU. Some sort of power saving you could implement with hardware too. A common ground for everything, MCU and sensors. And again, the 5 volt S minus 5 volt. Here again, separated sensors and extension board separated from the MCU. Again, so you can, this is the power from USB anyway, so you can work with that. We have the external going to the MCU here, only to the MCU. And then we have, this is just an open control. If you want that the MCU wants with one of its GPIOs to control an external activation of a power saving, this one can be used. Just going these few millimeters up to here. And the same with the other one, which you can wire them into any pin here where you think, oh, I want to use that for controlling externally some power savings or not. So you could separate cutting off 5 volt powers to the extension board and sensors. You could separate that from cutting off the power to the 3.3 volt for the external sensors. You can play, I mean, there are possibilities. So the board is open to use it differently as the most obvious ways to do it with the SPI, I2C, UART, and one wire. So you can play around with that actually, and you can modify it from time to time. Find your, depending on your setup. If you have found that setup, it's very easy for you to make 5 or 10 copies of this. So it's easy to make a series of this. So it's open to manipulation, but it's open to making serial productions too of some number. Okay, and I will just show you again the extension board. And this is just an example to grasp how it could look. This is from the version 1 and 2, LV5. And here you can see how we down here have pinholes for not used really, and up here you can see example of a use going over to one of the K6 to 9. So this configuration I use often for myself. There are some out here for 23, 22 is going over here for some controlling. Yeah. So this is just an example from the former version. Further questions? Right? And let me hear. Thanks.